So in the most general form, a first order ordinary differential equation looks like this. The left hand side is the derivative of the unknown function, and the right hand side is some expression, some function of the independent variable and the dependent variable. Right? So here are some examples. 1, 2, 3, 4, 5. Right? So in each case, the right hand side is our function f of ty. So here f of ty is e to the minus t square. I don't know. So here f of ty is 0.1 y plus sine t, and so on. Well, then an ordinary differential equation is usually visualized as a vector field. Well, a vector field is given by two coordinates, right? So the first, the x coordinate, and the y coordinate, or the y component, right? So two components. Well, by definition, the direction field of an ordinary differential equation, y prime equals f of ty, is the vector field whose first component is 1 and second component is f. Right? So if you still remember your calculus 3, we can also write it as I plus f j. Right, so the first component of the vector field is 1 and the second is f. Right, so here is the direction field of the differential equation 9.8 minus 2y. So what does it mean? Maybe let me explain. Let's look at any particular point, say this 1 and 5.5, right? So this is the point where t is 1, so this is the point 1 and 5.5. So t is 1 and y is 5.5. So it means that at this point, according to our differential equation, so y prime must be equal to 9.8 minus 2 times 5.5, which is 9.8 minus 11, which is minus 1.2. Right? So it means that at this selected point, our direction field has coordinates 1 and 1 minus 1.2, which is what you see. So it is, well, the 1 is the first coordinate, so it points to the right. The second coordinate is negative, so it points to the right and downward. And the two coordinates are almost equal, so the slope is almost 45 degrees. And this is what you see. That's the arrow. Well, now it is extremely important to know how to plot direction fields and how to relate a direction field to a differential equation and how to extract qualitative information from a direction field. But here is a little MATLAB or Octave code for you. Now, I suggest that you try to, I don't know, go to Octave Online, try to insert this code into Octave Online and see the output. So in future, you can of course use Octave Online, or you can just download Octave, or you can download MATLAB, or you can use MATLAB in our computer labs to plot illustrations to your homework. Now, why the concept of a direction field is so important? So why do we use the direction field to visualize a differential equation? Well, so note that once again, so the y prime is the slope of the tangent line to the graph of the function y, right? And that's the left-hand side of the differential equation. So the right-hand side of the differential equation is the slope of the vector, right? 1f. So this is the x component, this is the y component, and the y over x is the slope, right? Because if this is y, this is x, then the slope or the tangent of this angle is exactly y over x. So the bigger is the ratio, the steeper the slope. The smaller the ratio, it's more horizontal. So if y over x is 0, it means that y is 0. Well, and so on. So right. So for example, if f of ty is say 0, is f of ty is 0, it means that we're going to see horizontal arrow. The slope is 0. So if f is say some small number, then we are going to see an arrow of a small slope. So if f is say a large negative number, then we are going to see a steep arrow down, and so on. But it is important that the direction field is tangent to the graph of the function y of t at each point. So why is it? Because, well, the slope of the tangent line is the same as the slope of this vector. So it means that, well, the tangent line is parallel to that vector. And this is what we see on the picture. For example, now at this point, the vector is just a tangent vector to the line. And, well, informally, you can think of this as, so what it tells us, so the fact that the direction field is tangent to the graph of each solution at every point, it kind of tells us that all solutions, they sort of follow the arrows of the direction field, right? So if you want, say, to plot a solution, then you just need to go like this, sort of plot. Follow the arrows. And then it's going to be a good approximation to solutions. Maybe let me quickly explain it again. So I've prepared this little demo for you. Sorry. Oops. Hopefully it's going to work. Okay. So this is the direction field of the differential equation dy dt equals t minus y plus 1. Right? So here, the initial value of y is 1.5. So the point 0, 1.5 is on our solution. The black curve is a solution. So as you see, it kind of follows the arrow. So each arrow here is a tangent vector to this curve whenever, well, it belongs to it is attached to a point on the curve. So this fat blue dot is the point corresponding to the value of t is 1.2 and the value of y is whatever, so that the point belongs to the same curve. So this big black arrow is calculated as follows. Its x coordinate is 1 and its y coordinate is found like this. So here the y coordinate of the blue point is 1.65, and the y coordinate of the black vector is 1.2, which is t, minus 1.65, which is y, plus 1, and this is 0.55. So which means that here the black vector has coordinates the first coordinate is 1 and the second coordinate is 0.55, right? But if, say, you try to find the value of t somewhere here, so let's say 0.4, it's going to be almost horizontal, right? So here now it found the value of y, so that the blue point sits on the black curve. Now y is 1.41, but then the right hand side is going to be 0.4, which is the value of y, minus 1.41, which is the value of y, plus 1, so it's slightly, well, it's a very small negative number, which you can see the black arrow is almost horizontal, but it's a little bit points a little bit downwards, so to the right and a little bit downwards, and so on. And so you can play with it a little bit if you want to understand it better. So that's one little demo. Or here there is a free online direction field plotter, so that you can use during tutorials. So when you do homework, please draw proper nice illustrations. tinyurl.com ODE field. Okay, let me find it. Stop. tinyurl.com ODE. Yeah. And so here you can type the right hand side of your differential equation. Say, I don't know, t times y, and then you can graph the direction field. And then if you want to plot solutions of the differential equation, you can too. So here is a solution of the differential equation. Well, you can, I don't know, say cos t times y, and that's something different. Again, you can use this tool when you in class, when you do your team-based learning. At least it's very simple. Okay. Sorry, yeah, it's been a bit off. Well, finally, yeah, there is just one more quiz for you. Please try to solve the quiz to recap